So another misconception about the universe is that, like, the way sound travels in space, there's a lot of people that believe that there's no such thing as sound in space, but that's not entirely true. Objects can create sounds in space, but it's really more of the way it travels through space that is the problem, because everything's so spread out, everything's moving so fast. It might even be possible faster than sound travels. That's another thing. So if you think about it, you know, it's usually the way you got to really look at the way sound links or sound waves are created and the way they travel through time and space, or rather even on this planet. You know, it's usually a lot to do with the way things bounce off things. So like if you're in like an echo chamber, rather, like in a room where things can echo, you basically would be surprised that you could definitely hear, like, you know, pinging or something bouncing and echoing, because it gives off that vibrant, and the wavelengths still are going. As somewhere in space, there isn't really so much to do that, because the molecules that are required for it, or the way, again, sound waves, for example, you basically would have a better chance of creating like a special instrument, recording it, and then measuring it that way. You know, that's how they've done it in, you know, like science, for example. They've used things that could detect sound length waves from like long waves away, and radioactive waves, and electromagnetic radiation waves, and basically wavelength and frequency. So if it wasn't for certain instruments, basically it would be a lot harder to record it, let alone that it even existed. So you want a good example? I mean, you look at something like the WOW signal, which kind of threw a lot of people off for the years. And at the same time, though, you look at objects, celestial objects, that, you know, even like when we send like a satellite into space, or a satellite or a probe or what have you around like a planet or a moon or you know, an asteroid or whatever it is, you know, something that's going through space, constantly gathering data and sending it back somewhere else using nothing but frequency waves, it basically creates its own physics. And it also is using the universe's physics to be able to understand it for what it is. Because again, the best way to measure something is the way it happens. So with everything moving in space, I mean, you have like what is known as the sound barrier, and there are things that are even faster than the sound barrier. So with that being said, it's very possible that, you know, that's how you get a lot of different sounds. That's how you get a lot of different, you know, signals too. Because depending on the frequency and depending on how loud it runs is going to be how it works, or what kind of sound you're even getting, you know. Like, for example, like if something was to hit, like if you had something that was really hollow, you could hear something, you'd hear a different sound effect compared to something that, like if I hit a solid object, but it's so thick that it, like a brick wall, for example, would actually do that. You know, if I was to hit a brick wall, something like that wouldn't be able to do that. But I think what would be really interesting if you have like the hollow effect, and depending on how hard the material is depending on how the stuff will travel through space or wherever the project is. So it depends on the material, it depends on the sound waves, and it depends on how hard you're hitting it too, because that might also have a lot to do with how objects collide. You know, you have the impact, you have the wavelengths. And so really, if you really want to understand like what sound is and what wavelengths are, you really have to understand how they're produced, what produces them, and how long they last, the time that measures them. So that should kind of give you a good idea why certain things in space, for example, or certain objects are able to do what they do, whether it's through the motion and acceleration that they travel, or the pressure and the magnet fields that they can give off. Like, for example, like planets all have different sounds they give off, but why do they give off the sounds they do? It has a lot to do with their orbit, their rotation, the objects that orbit around them, their gravity, their magnet fields, all sorts of things, all sorts of different forces, accelerations, and, you know, just maybe the mass altogether. But whatever causes it, again, you know, it's probably best to look at the instruments and even the audio MP3 files that we have on record that we have been able to record and pick up. So hopefully that explains a lot, but just figure I'd make this video to explain that too. But sound is a very, very interesting thing, because it definitely makes you, and it's even proof, because there have been things that we have discovered that we can't visibly see, and people have said there's no proof this exists, but yet they can pick it off with sounds. And it's like, well, wait a minute, if we can hear it but we can't see it, it's got to be something still, or whatever that is. But again, subscribe if you're not already. I will make more videos like this, and I hope you have a wonderful day.